All right, here we go. Power Standard 7, I can Statement 3. Today's date is 9/28/2015. I can name triangles and classify angles of triangles. So guess what we're going to be talking about? Triangles. How many sides does a triangle have? 3. Very good. Probably review for many of you. I'm assuming that we're pretty proficient when it comes to the names. You'll probably be able to recognize the names. You might not know what they mean, but I'm sure you could definitely recognize them. First one. Equilateral. Actually, I think I spelled that wrong. Put an A there. Equilateral. Triangle. All 3 sides are congruent. In other words, all 3 sides have the same measurement. If one side is 3 centimeters, all 3 sides are 3 centimeters. If one side is 6 centimeters, all 3 sides are 6 centimeters. And this is what it would look like. I put those little slash marks through the side lengths just to let you know that all 3 of them are equal to each other. That's your key to having an equilateral triangle. When you see these 3 slash marks, that tells you, the mathematician, that all 3 sides are the same. You have an equilateral triangle. So I could give you a problem like this without any numbers and just say, what kind of a triangle is that? And you better be able to say equilateral. And the reason why is this symbol. The symbol that we use to designate an equilateral triangle are just these slash marks through the side lengths. Then we have what's called an isosceles triangle. This just means that 2 sides of a triangle are congruent to each other. Notice this time I did not put 3 slash marks through the sides. If I would have put in 3 slash marks, that would have been an equilateral triangle. So I only put 2. And the reason why I put 2 is because an isosceles triangle, 2 sides are congruent to each other. Anybody know what the third one is? Equilateral, isosceles, Aiden? Scalene, good job. So if we got one triangle where 3 sides are equal, isosceles 2 sides are equal, what do you think scalene is, Harris? One side? No. You can't have one side equal to itself. Sebastian? 0 sides. Zero sides, which means there will be no little slash marks. And if you can see, all 3 sides are different. Any questions about classifying triangles according to sides? Well, next up we have the classification of triangles according to angles. And there are 4. You have an acute triangle, an obtuse triangle, and a right triangle. And actually, we've already done them. This is acute. This one is a right triangle. And that one's obtuse. So those are the 3 definitions of acute. All 3 angles are less than 90. Obtuse, 1 angle is greater than 90. And a right triangle, 1 angle is exactly 90 degrees. And then we have number 7, which I will wait for you guys for. Because I know you've never heard of this before. I was right. Equilateral is spelled with an I. Isn't that weird? I think for the last, I'm 35 years old, so probably the last 30 years I've been spelling it equal, E-Q-U-A-L. Interesting. But equal, lateral is E-Q-U-I. Last, I'm sure one you've never heard of before. Equangular. It's kind of a fun word to say. Equangular. Equangular. It's like equal, lateral. But this one's equangular. If equilateral, lateral meaning sides, equal meaning the same. If equilateral means equal sides, what do you think equangular means? Look at the suffix. Emma. Right. All three angles are 60 degrees. All right, math students, here we go. If a triangle has three angles and all three angles are 60 degrees, how many degrees are in a triangle, Nathan? Come on, accelerated math student.
180.
Right. 180 degrees make up a triangle. And it does not matter if it's an obtuse, equilateral, equangular, isosceles, right, acute, scalene. Doesn't matter what kind of triangle you are given. Every single triangle is made up of 180 degrees. Okay? So what are we going to do with this? Well, there's a bunch of stuff we're going to do. The first thing that I'm going to want you to be able to do is identify these triangles. You need to be able to identify them. So we need to classify this triangle according to side lengths and angle measurement. For me, looking at this, I see two sides that are exactly the same. Not only do I see the two slash marks, but I also see the 8 and the 8. Those are equivalent. What do we call a two-sided triangle? Or not two-sided. What do we call a triangle with two sides equal to one another, Hannah?
Isosceles.
So this is called isosceles. And are all three angles acute? Do I have an obtuse angle? Do I have a right? Or are all three 60 degrees? Sebastian? And so that's how we would classify that triangle. Isosceles, acute, triangle. Or, what's another way to classify this? Watch this. This is crazy. Does it matter? No, it doesn't matter the order. However, the one that is a little bit more appreciated is if you put the angle first and then the side. But if you on a test put isosceles acute, obviously you would not get it wrong. Sometimes you will not be given the dimensions. And it might just look like this. Olivia, can you start us off and maybe classify that weird-looking three-sided polygon called a triangle? All right, scalene. And what would the other one be, Nicole? So we would say a scalene, obtuse triangle, or an obtuse scalene triangle. It's obtuse because this angle right here is bigger than 90. And it's scalene because none of the sides are equal to each other. How do we know none of the sides are equal to each other? How do you know? Olivia, you said scalene. How did you know that none of the sides were equal? There's no numbers up there. These look pretty similar. Those look pretty close. How do you know that that is a scalene triangle?
Because it's obtuse.
You can have an obtuse isosceles.
It's a scalene triangle because it has an equal 90 degrees and
The 90
the angle is like...
has nothing to do. Scalene has nothing to do with angles. Emma? Just by looking at the picture, how do you know it's scalene? Okay. What does an isosceles triangle have that the scalene triangle does not have? Nick? The lines. That's how you know it's scalene. There's no lines. Just like the equilateral triangle has 3 lines. The isosceles triangle has 2 lines. The scalene triangle has 0 lines. That's how you know. All right, let's try another one. See if you can do this one on your own. Zach, can you give us one classification?
Equilateral?
I agree with that. Remember, equilateral does have an I, not an A. And Emma? A right? No, right's 90 degrees. That's what right means. Right makes the L. Looks like an L. Christian? Very good. Equangular. And what does equiangular mean?
That means that all sides have 60 degrees.
All sides are 60 degrees? All angles are 60 degrees. Because if you notice, let me get out my highlighter here. Lateral, if you play football, means side. Angular means angle. And what does equal mean? The same. The same. So you have the same side, the same angle. Okay? Any questions about classification? You're going to have to memorize those. And it's going to be very important for when we do area of triangles, to be able to classify them. No questions? All right. Find the missing angle. So now we're still working with triangles. Now it says find the missing angle. We said earlier, well, Nathan said earlier, that all three angles add up to 180 degrees. So in order to find the missing angle, find the value of that angle, we would have to add the 95 and 32 degrees together and get 127 degrees. And in order to figure out what this third angle is, we would have to subtract 127 from 180. And you get 53 degrees. 53 plus 32 plus 95 add up to 180 degrees. Luke, where's your glasses? At home? Oh boy. That's not good. That's not good. All right, see if you guys can figure out the missing value for that angle. We have this angle up here, which is 34 degrees, and this angle down here, which is 28 degrees. hopefully everybody found the sum of the two given angles. You got 62 degrees. And then you subtracted that from 180. You got 118 degrees? Yes? All right. Fantastic. I'm going to throw a little curveball at you. Hopefully you guys swing and hit it. I'm going to give you all three angles. And I want you to tell me if it's possible for a triangle to have these three angles. Okay? You guys are going to have to YouTube the notes that you missed. I said you're going to have to YouTube the notes that you missed. So can a triangle have these three angle measurements, Jack? No. Why not?
Because I have to add up to 180 and add up to 200.
And we just found out that 47, 85, and 68 add up to 200 degrees. So there's no way. There's no way. It's not a triangle. I don't even know what it is. Some crazy looking shape. Are there any questions about this? Last example for today. Now I'm only giving you one angle and asking you to find the other two. Very simple.
Does that open equal 360?
Absolutely not. It's a triangle. I know you weren't here, you just came in. But a triangle equals 180 degrees.
Okay. So
How many x's do we have up there?
2.
So then we start out by writing 2x because that's how many x's we have. To find the measurements, correct me if I'm wrong, but have we been adding this whole time? So we have the two angles plus the third angle equals, what is it going to equal? 180. The reason why I have two x's, 2x, is because literally there's 1, 2x. 1 and 2. So that's 2x. And we'll add to the 2x the 128, because, correct me if I'm wrong, but didn't we add all three angles together in that last example? Okay. So we need to make sure that we add all three angles together. What do we do from here? Starts with an I. Inverse, good. And 180 minus 28 is 52. And then we just divide by 2. And x equals 26 degrees. So if this x is 26 degrees, what's this x? 26. Very good. All right, that's it. No homework tonight. We'll have classwork tomorrow, a lot of it.